So I'm going to talk a little bit about what's being done and the things that can be done. So this is a little bit of data from a recent draft report, that's still in draft, about river and lake swimming in Canterbury. And what it shows is some data as to why people had stopped using or stopped swimming in rivers and lakes in the region. And what we see, is it this one? What we see is the main reasons given are pollution and low flows. So problems with water quality and problems with water quantity. So this is what I'm going to focus on in terms of what can be done, what's being done, what can be done for water quality and water quantity in the region. But I'm just going to start with a very, very quick overview about the origins of some of these issues, building on what John has already talked about, because it's really important to understand where these things come from if we're going to try and manage them. So these are some of the contaminants that John's already told us, the reasons why we're interested in them in terms of swimmability and contact recreation, and the reasons why we're interested in them. And here are some of the sources. So again, John talked about these, and I don't want to talk about them in any kind of great detail, except to make the point that these contaminants don't just come from one land use, and they don't just come from the rural sector. They actually come from lots of different sources and all over the catchment from both urban and rural areas. So we know that these things are important, or we know that they impact on things that we value. So after knowing the types of activities that generate them, we need to know how these contaminants move through the environment. So in general, not exclusively, but in general, sediment and phosphorus and fecal microorganisms go over the surface of the land, and in general, nitrate moves down through the soil into groundwater. So there are two quite different flow pathways, and these flow pathways can give us clues to how fast these things are going to move, which is also really important for management. So if we took one extreme, fecal microorganisms, for example, these have, as John said, they come from the gut of warm-blooded animals, and they have quite high die-off rates as soon as they come out of the gut. So if there are kind of samples, if there are fecal microorganisms in a sample of water in a particular place, they're likely to have come from a reasonably localized area and from a kind of a reasonably recent time frame. So I went down to a popular swimming point at the bottom edge of the Selwyn, or the bottom end of the Selwyn River this morning, and I took a little sample. So if we were able to trace where the fecal bugs from this sample came from, they were likely to come from the little red circle here, just in this, likely to come from this kind of area, and they were also likely to have been lost since the election. Okay, so if we could age date them. If we go to the other end of the extreme, if we go to nitrate, it's quite a different matter. Because of the way nitrate moves, it actually comes from the whole of the catchment. So in this sample that I took this morning, we could have nitrates that were lost on some or all of these world-famous days. So in the same sample that was taken on the 18th of October 2017, we could have nitrate that was lost on the day that Nelson Mandela was imprisoned and the day that he became president of South Africa. So thinking about that, the reason why that's important is that for N especially, there can be really long lag times between what happens on the land and when we see the impact of it in the water. And that causes quite a lot of complexity for management. So that's the way contaminants move, but what about the water itself? So I'm going to give a very generalized picture of the general flow paths. I'm no hydrologist, but if we think about kind of mountains, hills, plains, as rain and precipitation falls on the mountains, it kind of drains out of the mountains, tends to into these the big alpine braided rivers, the Waimakariri, the Rakaia, the Rangitata. These tend to, or we think that these form kind of barriers. We don't think that water tends to move underneath them, although ECAN is doing a little bit of work on that at the moment, just a little bit more research. But these rivers tend to lose water out of the sides into the groundwater zones on either side. We've got rainfall falling on the hills, comes out of the hills in rivers and streams, and again tends to lose some or all of its water down to groundwater. And then rainfall that falls on the plains, again, most of it goes down to groundwater. This groundwater then moves towards the coast, and at some point as it gets towards the coast, it starts to recharge, it starts to come back to the surface, and we get lots of kind of spring heads and those lowland streams. So that's about the kind of general flow paths, but picking up on the problem with flow is around low flows that we've seen. So I'm sure that many people will have seen in the press over the last kind of 6 or 8 months problems and concerns around low flows, especially in the Selwyn at Coast Ford, which actually stopped flowing this year. So in a recent seminar series, the Selwyn seminar series, I don't know if anybody went to it, but Tim Davey, who we heard from this earlier today, he spoke at that seminar series talking about why we've seen some of these problems with low flows. And it's quite tempting, or it can be quite tempting for some people to say it's all about irrigation, it's just irrigation takes that are sucking the aquifers dry, or it's all about climate variability, irrigation's got nothing to do with it. And actually, what Tim showed us, it was a combination of the two. And I've got a slide here from a colleague of ours, Bob Bauer from WGA, and this is actually some data from the Hines, so a little bit further south, but I think it really shows this kind of the combination effect quite nicely. So here we've got this is depth to groundwater, and this is over time, and this is so we can see the kind of climate-driven variability and the difference in groundwater levels between the kind of wetter seasons and the drier seasons. Then mid to late 1990s, we had a couple of things happen. So one, increased groundwater takes, and two, and this is quite interesting, increased efficiency in stock water and irrigation schemes. And this is what happened. So we've still got that big kind of climate-driven kind of variability, but because we've got less water in the system, it's exacerbated the effects. So when we get to those super low flows, or when we get to those drier periods, actually the flows are that much lower. We'll come back to a bit of Bob's work later on. So that was just a little bit about the causes of these things. I want to spend the rest of the time talking about what's being done, what's being done now and what could be done. So first up, what's being done about nutrient pollution. So in 2013, Canterbury released their, or was notified, is it notified or it got accepted? What's the word? I can't remember the word. Basically, it got, the plan was notified and accepted, a Canterbury Land and Water Regional Plan. So this has set kind of regional lines in the sand. So all farms over a certain size, since 2013 have had a nitrogen loss allocation. So they've got an allocated piece of the pie. So that's nearly 4,000 farms. And that allocation has been based on historic activity, so what they were doing between 2009 and 2013. Then each of the zones, there are 10 zones in the region, are invited to go through a more detailed limit setting process. So this is water quality and water quantity limit setting processes. In the Hurunui, in the Selwyn, Hines, South Canterbury and the Waitaki have all been through this water quality, this limit setting process, and they've set water quality limits and in some cases they've allocated them back to the farm, and in some cases that has required more than good management practice. So they've actually got to go beyond good management practice because the water quality has been quite impaired. Many farms are required to have farm environment plans. So these are linked to consents. So their farm environment plans cover not only those nitrogen loss limits, but they require farms to operate at good management practice. This good management practice covers things such as water, nutrients, riparian, effluent, soil management. And the farms are independently audited, and more than 3,000 of them have been done to date. But it's really important to note that it's not just because a farm has a limit or it has a farm environment plan that anything actually happens. It's actually implementation is really key. So this is where the farming sectors and rural professionals have a really important role to play. On a slightly different note, something else that's going on at the moment is the Our Land and Water National Science Challenge. One of the research projects is researching concepts of land use suitability to try and understand what types of land are more suitable for different types of land use, given their inherent characteristics and the riskiness of the environments that they flow into. So some of this information is already used in those limit setting processes, but bringing it together, I think, could really help those limit setting processes in terms of the goodness of the decisions that they're making. What about things that could be done? So I was talking about those regional nitrogen loss limits being based on historic activity. Well, there is a variation to that plan being proposed at the moment, and it's in hearings at the moment, or it's in the hearings process at the moment. I think it's under appeal, about basing those limits not on kind of a step above that, so basing those loss limits on good management practice. Other things that could be done, new and diversified farm systems. I think these have a really big opportunity. I think Canterbury has a really big opportunity to look at different new diversified farm systems, opportunities that digital and agriculture and horticulture could bring. Use of robots, drones, sensors, probes, plant-based proteins, regenerative agriculture. So we've got, there are lots of little pockets of research or work going on these things, but we haven't seen anything big scale yet. Another opportunity that I think is further research, but also widespread investment in catchment scale approaches and interventions. So we're doing some stuff at farm scale, but there are some things that we just can't get at, we're not going to be able to achieve unless we look at kind of multiple farms or look at the catchment scale. So an example of this is actually a colleague of John's who spoke first this evening, who was invited to or who was asked to investigate the potential of constructed or enhanced wetlands around Lake Ellesmere, Te Waihora, by the Whakaora Te Waihora program. And he was looking at basically the potential of these things to reduce annual nitrogen and phosphorus loss. And what he found was that about 1.5 or 1.6% of the catchment, but in very, very specific areas, if it was put into enhanced and constructed wetlands, could actually reduce the annual N and P flux by 40%. So that's 40% a year. So that's something that you can't get at an individual farm level. You can only get if you look at a wider catchment type approach. So examples of what's being done about fecal microorganisms. So many of the same measures that are put in place for nutrients are actually really effective for fecal microorganisms as well. So farms operating at good management practice, farm environment plans looking at fencing, looking at bridging, wetland protection, improved practices for stock, effluent, riparian, and soil management, which are the real kind of key things on a farm for fecal microorganisms. Also examples, so ECAN using its monitoring data to try and identify hotspots. So it's got some monitoring data on the Selwyn River that identified the Silver Stream, which is a little subcatchment into the Selwyn River, as carrying really high fecal microorganism loads. So basically using that data to target actions, going and then kind of working in a concerted effort with farms in that catchment to reduce the loads. And also something else that I thought was quite neat, which was I don't know if anybody's had a look into the what's it called, Dig a Little Deeper, Look a Little Deeper, the Canterbury Water. So it's by ECAN, but it's under the Canterbury Water strapline. And so this is the series of little cartoons, but they're aimed at people in urban environments and talking about what people in urban environments can do to basically help manage their impact on fecal microorganisms, but also on nitrogen and phosphorus. So a bit of education in there too. In terms of what could be done around fecal microorganisms, so improved wastewater, improved stormwater. So this is definitely something that we see in the centre. We've got lots and lots of subdivisions going on, but also in our rural centres. And another bit of technology that actually I only came across last week is something called eShepherd. And I don't know if anybody else has heard about this, but it's basically a technology where you basically have stock that they have collars, and the collars have got a GPS kind of signaler on them, but they've also got the ability to give a small electric shock, like an electric fence. And so on a digital map, on a GIS, you can basically trace out where you don't want the stock to get into. So these are the kind of thinking for those first, second, third order streams that would be really, really difficult to fence or really uneconomic to fence. You could basically draw those on a map, upland, wetlands and things, and every time the stock go near them, it's like them walking into an electric fence. So I just thought, I don't know if anybody else has heard of it, but I thought it was a really interesting bit of technology. So coming towards the end, examples of what are being done about low flows. So that was something about contaminants, but what about flows? So the sub-regional water quality and water quantity limit setting processes, a couple of things that they're looking at are re-looking at minimum flows and also looking at more appropriate water allocations. So minimum flows, they don't put water into a river, but they can stop people abstracting it and reducing the flows even further once it gets to a particular point. There's also been investment to improve the efficiency of irrigation schemes, reducing the amount of water that they need to take for any given area. Although I've actually put a little asterisk, I don't know whether you can see a little asterisk there, because as I talked about before, sometimes this inefficient irrigation has actually provided kind of dilution or unmanaged aquifer recharge. So actually when we go drive to more efficient irrigation systems, which is really important, we need to think about the kind of interplay between water quality and water quantity. But there are also some examples of some more direct action that we've seen in the region. So targeted stream augmentation and also managed aquifer recharge. So there's been a pilot, I don't know whether people are familiar with the pilot, managed aquifer recharge pilot in the Hines catchment, but this is basically where clean water has been infiltrated near the top of the catchment to augment the current groundwater system. And our colleague Bob Bauer has lent me a couple of slides again, showing he's one of the people that's been involved in running this pilot. So this is basically a kind of a cross section down to the groundwater system, and this is kind of the distance from the infiltration site. So it's a little kind of animation that shows what's happening as the water is being infiltrated. A little bit further, onto a couple of months, and then onto 3 months. And they were starting to see increased groundwater levels. And then I don't know whether we'll see it in the light, but also what's happening in terms of groundwater concentration. So this clean plume of water coming through, seeing, where we got it? Groundwater concentrations around about 2.5, compared to the 12.5 that we see without that clean plume, without that dilution. So that pilot is proved quite successful and is expanding. I think it's been approved into a kind of a fuller scale project, and I think can lead to a lot more kind of innovative ways of looking at ground and surface water management. But in the longer term, the flows are basically not going to be, low flows are not going to be effectively managed without revising the ground and surface water limits and allocations, so clawing back where it's been over-allocated. And there are some examples of this, but quite often, even when the planning mechanism is put in place, it takes quite a long time for the impacts to come through the system. Example of this is happening right now in Canterbury with a local irrigation scheme. So it's an existing irrigation scheme that's mainly groundwater fed, and it's being expanded by importing water from outside of the catchment. And so what they're doing is that transferring the people who are currently taking groundwater onto the new imported surface water source, but then those people can't transfer their groundwater consent. So the groundwater they would have taken is now being left in the ground and collectively leading to higher groundwater levels and ultimately higher flows somewhere down the system. So those are the various things that other people are doing, but there are also things that we can do as individual users when we're when we're looking at kind of swimmability. And these are touching on a couple of things that Tim and John have already talked about. So one is the LAWA website, basically being able to, it's a really great website if you haven't had a look at it. So being able to go and have a look at a particular site and seeing what the most recent water quality data was. But as Tim mentioned, it might be up to a week old during the swimming season. So basically wanting to be able to kind of improve our own ability to make decisions about whether something's safe to swim or not. And a colleague of John's has done some research quite recently to try and understand the relationship between clarity and contact recreation risk, to try and support people's kind of own decision making when it comes to basically should I dive in or not. So I think if there are any questions about that, we can ask John to elaborate a little bit more in the discussion. So in a nutshell, water quality and water quantity are the main reasons that people have given why they've stopped swimming in Canterbury rivers and lakes. There are many sources of the contaminants that cause these problems, and their flow paths are quite varied and making the management quite complex. There has been and is an ongoing concerted effort to manage these sources through things like stock exclusion, nitrogen limits, farm environment plans, good management practice, as well as a whole bunch of other regulatory and non-regulatory measures towards water quality and water quantity. And I think there's always also a lot of great potential for interesting and new technologies and diversified farm systems that can help assist us on that pathway to swimmability in Canterbury. So there is uncertainty, absolutely, about whether all of these measures are going to be sufficient, but what there isn't any uncertainty about is that actions are necessary. Thank you very much.